So there's a small theory stating we therefore base the reinforcement design on the maximum bending moment in both directions and reduce the amount of reinforcement to 50% as the bending moment tends towards zero, moving towards the supports. So basically, after calculating the bending moment in both directions, spanning in this direction and spanning in that direction, we can determine the steel sizes that we're going to need. And what they mean with that's basically what they mean with we base the reinforcement design on the maximum bending moment in both directions. And then there's also a section where they say we reduce the amount of reinforcement to 50% as bending moment tends towards zero. So what we mean with that is that where your bending moment tends towards zero at the supports. Now that's where we minimize or we reduce the amount of reinforcement to 50%. And how we do that is when you look at the sketch, what we do is we basically use alternated bars in reverse, and that's just going to reduce the amount of steel from face of the slab to your beginning of your bar on that side, and the same as on this side. So if we cover the whole area with bars, then what that actually does is that it reduces the amount of steel in this area to 50%, because that's the area actually where the bending moment is equal to zero on both directions. The same as for in this direction and that direction. Where the supports are, the bending moment tends to zero, and that's why we are reducing the steel to 50% all the way through. And this is just a sketch of your section view showing the wall support here, the wall support there, and then basically the walls support in that direction.